the different kinds of VPN models which we use in today's networks. So in the previous section I have explained you that how VPNs models or different kinds of VPNs are more effective and the cost effective when you compare with the these LAN connections. So VPNs can be offered in two major models. Now majorly we have two categories of VPN models. We have something called overlay model and P2P model. Now the basic differences are, let's say overlay, in case of overlay, all your frame relay, ATM, X.25, Ipsec, GRE, these are all comes under the category of overlay model. And when you talk about P2P model, our MPLS comes under the category of the P2P model. Now what's the difference between these two, overlay and the P2P model? Let's take an example. This is my service provider network. Already he is having some connection, dedicated devices inside the service provider network, and then I have a customer site A want to connect a customer site B, or site 1 want to connect to site 2. Now VPNs provide a virtual dedicated point-to-point connection between two different sites. So now we are going to have a not dedicated actually, it's a virtual point-to-point connection is provided, and which goes through the service provider network. That is what VPN is going to provide when compared with the leased LAN connections. In case of leased LANs, we have a separate dedicated point-to-point links, but here it's a virtual point-to-point links. Now the basic differences are in overlay model. Now the service provider provides a virtual point-to-point connection between the customer sites, okay, without actually exchanging the routing information, which means now we are going to provide a connection to the nearest service provider device, that is the PE device, and then we are going to connect to the nearest provider edge device here. Now the service provider is going to provide a virtual point-to-point connection between these two. So it's a virtual point-to-point. It's more like a tunnel, it's more like a tunnel. In case of GRE, we call as GRE tunnels, and even we have something called IPsec tunnels. In case if you talk about frame relay, now that virtual point-to-point connection is established with DLCI values. If you talk about frame relay, how it works, now we have a something called DLC value 102 is mapped with something called 201. There is a mapping of 102 to 201. That is how the overlay model is going to provide you the virtual point-to-point connection between the two sites. Now the major difference is here the customer traffic enters as a normal IP packet. Now once it enters as a normal IP packet, this IP packet is encapsulated with some extra information or extra added information. In case if it is a frame relay, it is going to add the DLC values. If you're using some GRE tunnels, it's going to add some source IP, destination IP of the header, something like that, and then the traffic is encapsulated to the other side of the network, and then it will be sent as a normal IP packet. So which means now we can run a routing between customer to customer directly without actually interfering the routing between the customer side. So the service provider is only responsible for providing a virtual point-to-point connection between the two sides. That's how your overlay model works. So you are much aware of the frame relay. You just think about frame relay, you will automatically understand how overlay models exactly operate. But when I talk about overlay, now I'm not going to say that the frame relay or IPsec is also going to work in the same manner. IPsec totally works in a different way. GRE also works in a different way. The main difference is in overlay model, the service provider do not know anything about the customer route. They just forward the packet based on that extra information added on the header. Whereas when you talk about P2P model, especially our MPLS L3 VPNs, which we'll be discussing the major topic in our course here. Now in case of MPLS, the same thing. Let's say this is a service provider. I have a customer on both the sides. A customer site 1 want to connect to customer site 2. Now we are going to provide a connection from the customer to the nearest service provider device, that is the provider edge device, and the customer connects to the nearest provider edge device. And here what happens is we are going to run routing between PE to CE, which means the customer routes 10.network will be advertised to the service provider router, and the service provider router is going to maintain the customer routes in the routing table. So service provider is actually participating in the customer routing. That's what I wrote here, in which the service provider participates in the customer routing. Now same thing happens here. Now this 20.network, the customer will advertise those routes to the provider edge router. sorry, this is my provider edge and this is my customer edge. Okay, so now this 22 network will be advertised to the provider edge router, and the provider edge router is going to maintain that routes in its own routing table. And then between, now what provider edge will do, then you have a logical VPN type of connection established between these two. Now this provider edge router is responsible for exchanging the routes with another provider edge router. Now which means your routes come from the customer, goes to the service provider, and service provider is responsible for sending those routes again back to the other end of the provider edge router, and then from there again the provider edge router will pass on those routes to the customer edge. Now this kind of implementation we call as a peer-to-peer model, and your MPLS L3 VPNs, which we'll be discussing the major topic in your MPLS, comes under this kind of implementation, this kind of category. Okay, but anyway, I'm just going through with all different kinds of VPN, just an overview, just trying to understand. So let's get started here. So the classification, I got a VPN classification. We got two kinds of models. Overlay model, where the service provider is not responsible for sharing any route from the customer. It's just provide a virtual point-to-point connection, that's it. So it will not participate in any of the customer routing information. Whereas here, in case of P2P model, our MPLS comes under this category, where the service provider is responsible for taking the routes from the customer and responsible for sending on the other edge of the other provider edge router and then back to the customer. And when you talk about overlay models, again we got L2 VPNs and L3 VPNs. Now in overlay we have L2 VPNs and L3 VPNs. Now the difference between L2 VPNs and L3 VPNs is, if you just try to understand the difference between frame relay. Now in frame relay, what we do in general, in a frame relay you have a customer on both the sides, and then also we have a service provider here. We have a customer and service provider on both the sides, and now your traffic from the customer comes as a normal IP packet but enters the service provider, and the service provider will not identify your traffic as a IP packet. It's going to forward from one side on the side based on the pure layer 2 information, that is your Del C values. Just like switches forward the packets based on the MAC address, it's more similar to that. That's what we call as L2 VPNs. Whereas when you talk about L3 VPNs, now in case of L3 VPNs, overlay L3 VPNs, now your customer traffic, customer packet between the two customers, we have a service provider, and your traffic comes as a normal IP packet, and your IP packet is again encapsulated with another IP packet, which means now you have a logical tunnel. If I'm using GRE tunnel, you have a logical tunnel established from point to point, and the reachability from this end to that end is provided based on the complete IP reachability. Now, which means the service provider is not using any DLCR values. It's going to provide the reachability from one side to another side based on the pure IP packet, and it's not going to see the customer traffic. As I said, your normal packet will be encapsulated with some extra header information, the source of the tunnel and destination of the tunnel. So the source of the tunnel is 11.001, destination tunnel is. So any traffic coming from this side will be automatically forwarded to the other end of the tunnel. So it's a pure based on IP reachability. So this is the major difference between these two kinds of categories. Now all your GRE, TM-VPN, IPsec, L2DPv3, SSL VPNs, these are all comes under overlay L3 VPN kind of implementations. So the one L2 VPN kind of implementation, we have a frame relay. We are much used to the frame relay in our basic CCNA studies. So we are not getting into this overlay model anyway. Our main focus will be on MPLS VPNs, but we are just trying to understand the different kinds of VPN implementations here. Now let's try to see how these P2P models are going to work in our scenario here. Now in P2P model, before we actually used MPLS, there was some other kind of implementations. We have something called ACL, shared router, and split routing concepts. Now there are some disadvantages with these two kinds of implementations. Let us see what exactly and how exactly P2P VPNs works in our scenarios when we use MPLS. This is what we discussed, a frame relay and all those stuff. Now in P2P model, as I said, the customer will be advertising its route. Let's say this is 10 dot network. He advertises his routes to the provider edge router, the P routing information, and then this P is responsible for sending the routes to the other end of the P router. and then this PE again sent back to the customer routes. This is how your P2P is going to work. But now let's take an example in this diagram. Now there might be a possibility that you have more than one customer connecting on the same router. Like in this scenario, you have a customer network, 10 dot network, and there is another customer using some 20 dot network. Now he's advertising the routes to the provider edge router. At the same time, the customer XY, both the customers are advertising the routes. Now how the provider router is going to differentiate the routes between them? So how is going to prevent the customer routes coming from X not going to B? Now to prevent that, we use something called ACLs initially. Now we don't use anyway ACLs. Now when you define some ACLs saying that any routes coming from this side, or some route filtering methods we need to apply, mentioning that whatever the routes coming from this side should not go on the other side, or whatever the routes coming from this customer X should not go to customer Y. So this was one of the initial implementation. That is one solution we can go with before MPLS. Now there is one alternate option you have. Instead of connecting to the same router, let's go with alternate option here. The alternate option is we can have a split routing or a dedicated router for each customer. Now your customer X connect to a separate router, customer Y connects to a separate router, and then anyway we don't really exchange any routing information between these two. Now in the previous scenario, we are connecting customer X and Y into the same router, but this time we are using two different routers. But again, this is also not scalable solution. If you have hundreds of customers, now we need to have some hundreds of provider edge routers, which is not again a scalable solution. Now MPLS VPNs is going to solve all of these problems. Now in MPLS VPNs, what we have is we have a concept of VRF. Now what this router is going to do is we have a concept of virtual route forwarding. Now what it is going to do is it is going to maintain a separate routing table for each and every customer. So even though physically it's a one router, but still it's going to maintain virtual routing tables. Now it's going to maintain one global routing table. It's going to maintain one global routing table, which will be the default routing table for the service provider network. It will be used for the service provider network, and then it's going to maintain a separate routing table for X customer, and a separate routing table for Y customer, and separate routing table for the next customer. And by default, now one router is going to maintain 4 different routing tables, and each routing table is isolated with each others. Now we don't really need to write any ACLs to prevent the routes going from one customer to another customer. Now what we can do, by default, the provider edge router will have something called VRF. So we'll get into more in detail about these concepts, but this is what our MPLS VPNs will actually provide. One of the most commonly used WAN technology in today's networks. We call them as MPLS L3 VPNs. Now why we call L3 VPNs? Because we are going to take the customer routes and we are going to maintain those routes in our routing table before they are again forwarded to the other edge of the provider edge router, and these routes are maintained under the VRFs in a separate routing tables, and each customer route is isolated from other customer. So let us see what are the advantages and disadvantages and the drawbacks of the overlay model and the P2P model. So when you talk about overlay, we need to think about frame relay or IPsec, GRE kind of implementations. So frame relay is not much used in the production networks now, in today's networks, but still. So when you talk about overlay model, they are very well known because we have been using for many years. So and they are very easy to implement because most of the people are very well aware of these implementations. And here the service provider is not going to participate any of the customer routing. That's what we discussed. Overlay model, the service provider will not receive any routes. It is only responsible for providing a virtual point-to-point connection between the two customer sites, but the service provider will not at all participate in any of the customer routing information. Now customer networks and the service provider networks are completely isolated, which means the customer and service provider, they whatever the routing they do, they are not at all relating with each other. They are completely different. So these are some of the advantages we get in the overlay models, but at the same time we have some disadvantages here. With overlay models, the more number of virtual circuits. So this is one of the major problem with the frame relay. Let's take an example. I got multiple customer sites and you're providing a connection. If I want to have a connection between each and every side. I want to have a full mesh, we need to have a separate virtual circuit from here to here, separate virtual circuit and separate virtual circuit from like this. Again, it is not going to provide the redundancy. So more number of connections we require, we need to have more number of virtual circuits, which means it's really going to add more overhead on the service provider to provide a virtual circuit. The same thing happens with the GRE also. If you want redundancy, you need to have multiple virtual tunnels established, GRE tunnels established from each and every point again. So it's going to, that is one of the major disadvantages. And virtual circuits has to be created manually, and then bandwidth has to be provisioned side to side basis again. And the overlay models will add some encapsulation overhead, because whenever you're sending a packet, a normal IP packet, once it enters the service provider, it is going to add some extra GRE or IPsec header informations, or if you're using frame relay, it's going to add some DLC values. It's going to add some extra overhead on the routers to add and remove that encapsulations. Now when you talk about peer-to-peer models, so when I say peer-to-peer models means just think about MPLS, because we have any other models as well, like, so we'll be talking about MPLS L3 VPNs here. Now the major advantage with peer-to-peer model is it guarantees the optimum routing between the customer sites, because now once it enters the service provider is going to maintain the customer routes. It's going to provide the best shortest path to reach the other end of the provider edge router, and it's really easier to add additional VPNs. Now it's really easy because when we get into that VPN concept, we'll see. So whenever you want to add a one virtual point-to-point connection here, it's going to be very easy because it uses one similar kind of implementation like RR servers we have in PGP. So we don't need to have a separate point-to-point connection for each and every site. We can still use a concept of RR servers just like we do in BGP, and we can have a virtual point-to-point connections like this. We don't need to have a separate VPN from here to here each and every site. We can have each P router can connect to the centralized device, and then from there again we can have a multiple VPN establishments. So it's going to be very easy to add an additional VPN when you compare with the previous models, and the only sites provision, not links between them, which means whenever you add any new customer site, we just need to add a link here, because this router is already connecting to the other side of the provider routers. So we don't really need to add a virtual VPN from this side or the side. So most likely we just need to add just a link connecting between this P to C. That's it. So one of the drawbacks, again, the service provider is going to participate in the customer routing. That is one of the drawback, and you need to ensure that you apply some filtering applied to the customer links. But anyway, service provider will ensure that your customer routes will not go from one customer to another customer. They're completely differentiated through VRFs, but that is one of the disadvantage we can say. Now the service provider is majorly responsible for customer convergence. That is the customer router when it comes to connect to the provider edge router. Now the service provider need to ensure that the customer route should get converged between C to P before they send to the other side. So that is one of the thing we need to consider when we are using P2P models. And the P routers carry all the routes from all the customers. Now the same provider edge router might be connecting to multiple customers, and it is responsible for carrying all the routes for all the customers. And we need to provide a secure environment between the customers. Anyway, that is something the service provider has to take care, ensuring that the no customer routes from one customer should not go to another customer. It's going to be a little bit complex configurations, but it's going to provide a huge advantage. So if you just list out these disadvantages, I can say P2P models are very much provide some good advantages, much more better than when you compare with other VPN models. The service provider need to have a detailed IP routing knowledge. So this will not make much difference when it comes to MPLS. So MPLS is one of the kind of P2P models which is going to carry the customer routes in the form of labels. Again, it's a completely different thing. So we don't, and one more advantage we get in the MPLS is especially now the service provider is not going to maintain. So I can say MPLS comes under this kind of VPN technology, but at the same time it's a kind of a combination of overlay model and P2P model. So when you talk about MPLS technology, it has advantages of both overlay model and the P2P model. So this is something I'll give you some more in detail introduction in my next video. So probably we'll see that much more in detail, like how MPLS is going to provide the best of the both models.